What's up, y'all? I'm Tom, and this is Like a Math Class. In this video, we're continuing on with our idea of concavity of curves, looking at the second derivative of a curve, and we're going to see where is this thing opening upwards, where it might look like this, and where is it opening downwards, where it might look like this. Let's get to it. So we're starting with the same equation that we've been doing through all of our other videos. We have previously found that the derivative, the first derivative of this, is 6x squared plus 12x. And now we want to find what is the second derivative of this function. And the second derivative is just going to be 12x plus 12. So we want to find out where is this function positive and where is this function negative. First thing we have to do is we have to find where is this thing equal to 0. So we're going to set this up where we've got 0 is equal to 12x plus 12. So we're going to subtract 12 from both sides. So we got 12x equaling negative 12, divide by 12, and x is equal to negative 1. So when x is negative 1, this function is going to equal 0. Or I should say this function is going to equal 0. So our sign diagram is going to be very similar to that. So here we go, similar to what we've done with the first derivative function. So here is going to be our x value at negative 1. These are our x values. Up here we're going to be looking at the second derivative of g. And we're going to look to see where is this positive and where is this negative. So we'll take some values on either side of the negative 1, just like we've done with the sign diagram for the first derivative, and we're going to check to see if we can find where these things are positive or negative. Then we'll also see where these things are concave up and concave down. So let's take a value, let's start with the easy one. Let's start over here at 0. We're going to make x equal 0. So now here we're going to put x is 0 up here. We're going to put the second derivative of 0, and we're going to find out where 12 times 0 plus 12. And so we're going to see 12 times 0 is 0 plus 12. So we're going to end up with a positive value. So up here, we're going to say we've got a positive value. Now, the other thing we're going to do is we're going to take a value smaller than this, and we're going to see, which we probably imagine, we're going to have a negative value over here. We're going to take the second derivative of g, and let's take it at, let's do negative 10. So we'll get a nice big number in there. So we're going to have 12 times negative 10, and that's going to be plus 12. Well, of course, this is going to give us a negative 120 plus a small 12, so that's going to be a negative value over there. So that means the curvature is changing at negative 1. If we were to try and graph this thing, we're going to see it says that our second derivative is negative, so it's going to be concave down from negative infinity to negative 1. And then it's going to be concave up, which is kind of a smiley face, like a U up. It's going to be concave up from negative 1 on to infinity. So we could say here that g of x is concave down on the interval of negative infinity to negative 1, and g of x is concave up on the interval of negative 1 to infinity. So that's how we find the concavity of a function. We're just doing the sign diagram again of our second derivative. If you found this video helpful, give it a thumbs up. And what we'll do is in another video, we will go through how do we find the sketch of the curve and how do we piece all of this together, looking at the first derivative, the second derivative, and possibly even the original function, and kind of piece it together coming in from different entry points. I'll see you there.